Or no, it wasn't 11:35. It was 3:59 in the morning. It was due at like 4 a.m. and it was 3:59 in the morning and 35 things or something like that. And I was like, please, I can't find class.
It stresses me out hearing about that.
And if you've ever had a class before, oh my God.
All right, let's go ahead and get started. So, Zoomies, hopefully you can still hear me. If at any point you can't hear me, go ahead and type into the chat box, and I will be able to see that as that comes up. Also, if you have any questions, go ahead and type in the chat box. All right, let's go ahead and get started with class. So what did we learn last time? It's going to include you on Zoom. You can unmute yourself if you want to talk. Okay, we learned what human factors is. And what did we learn?
We learned not to use your intuition on human factors projects.
Yes. So as Hannah said, we learned not to use your intuition on human factors projects, right? We like to think that we can just rely on our intuition, right? That's one of the big criticisms of psychology. Of course, it's just intuitive. It makes a lot of sense. But as you start getting into it, you start seeing a whole bunch of plausible explanations in any scenario wherein you don't really want to be relying only on intuition, because intuition can lead you astray. And that led to all of those contradictory aphorisms, like out of sight is out of mind. What is distance makes the heart grow fonder? What else did we learn? Yeah, Emmanuel.
We learned about the human factor design process, and it's a cycle, it's a continuous cycle, and that creates an environment of continual improvement, I guess.
Exactly, yeah. So we're always looking for continual improvement. It's not just a one and done. It's constant iteration and kind of reevaluation, reiteration, etc. Dennis says, we learned it involves safety, performance, and satisfaction. Absolutely. And so those are kind of the three primary things that we're going to care about within human factors. Are we concerned about the safety? Are we concerned about the performance? Are we concerned about the satisfaction? And so what type of domains would we care primarily about safety? Yeah.
Office building, like
Okay. Yeah. So potentially office buildings, particularly any high-risk domain, right? And so we're coming in, and while we care about exactly, Dennis. Yep. So while we are caring about the performance and the satisfaction, what we really care about is keeping people out of the hospital, right? What sort of domains are we really caring about satisfaction?
Like, we don't really care. I mean, well, to an extent, facility, you're not trying to make the worker happy per se.
Mm-hmm.
You're really trying to make the customer happy is the end goal.
Exactly. Yeah. And so, yeah, you're on a roll there, Dennis. Awesome. So yeah, anytime we're dealing with the consumer or the customer, we really care about that satisfaction, right? I talked last time about my strict adherence to Apple products. As you can see, as I'm a walking, talking Apple advertisement right now with the watch and the iPad and the MacBook. And it's not necessarily that they're the best products. They've just created a seamless integration between the products that makes it really easy once you have one product to just continue to buy the other ones. And so you can easily make the case that there are actually better products, better performance products out there. But Apple has done such a good job enhancing that satisfaction.
But what did you, on the site, just out of the,
yeah.
Also kind of lock you in though. I mean, like, make it where, like, I've looked at mobile phones. I'm not really too dedicated to any certain brand. I mean, I like Windows better. I like that kind of stuff better, like Intel and stuff. But I'm not a huge fan of MacBooks because I don't like the design. Like, I'm using I'm not saying they're not better as far as actual performance-wise, like actual, like, down to the grid. Like, yes, they perform better and more power. But as far as the interfaceability, Windows better. But the iPhone, I've had one for so long now. I'm almost like, I know how to use Android and all that, but I feel like I'm just not as, I don't know what it is. I don't want to transfer all the stuff. I'm already used to the way iPhone works. I know everything about an iPhone. There's no.
It's a convenience factor. Yeah. Yeah. And so absolutely, to a certain point, they're just hoping that you've kind of engendered a certain feeling of satisfaction just because you don't want to lose kind of all the benefits you've developed over using an iPhone for 10 years, right? You don't have to transfer all your contacts. And that's why a lot of these companies will make it really easy, or at least try to make it really easy to make that switch. You know, bring us your iPhone and we will transfer over all these contacts and everything for you, all your calendars and stuff like that. And so you are really trying to still enhance that satisfaction to get people in the door. But once they're in the door, you want to keep them around. And sometimes that is just a convenience factor. Sometimes it doesn't make sense for the individual consumer to switch over. But other times it is because they just enjoy that product, or maybe they don't know about the other products to the degree that they would have to make that switch. All right. Any questions about what we covered last time? Easy peasy. Well, if you do have any questions that come up about last time, especially those of you all on Zoom, go ahead and just type them into the chat box and I will answer them as they come up. Here is your fun fact of the day. Ravens in captivity can learn to talk better than parrots. And a dual fun fact, crows are apparently incredibly smart to the point where if you like harm a crow or you attack a crow, they'll frequently communicate with the other crows. And there have been documented cases of like murders of crows, is what they're called, groups of crows, coming and attacking people after they had attacked a crow. So, double fun facts.
Well, let's not wish more bad luck on 2020.
What's that?
Let's not maybe more bad. I don't think crows.
Yeah, crow attacks. I know, my goodness. I mean, it does. I'm not a particularly religious man, but it makes the books of Revelation look a little bit more like a prediction of the future now with everything going on. All right. So we're going to talk about design today. We're going to talk about different design approaches. But what do we mean when we say design? And so your book comes up with a list of 6 different kind of descriptors of the design process. First is creating new products, systems, and experiences. You then have that process by which you're improving, existing products and services, like we talked about last time, that kind of iterative process. And we'll talk about things like the Scrum approach today for that iteration. Ensuring safety-related activities such as hazard analyses, industrial safety programs, and safety-related training. So anytime you are onboarding at a new company, you've likely been put through some amount of safety training, even if it's just a, don't run in the kitchen type thing. You still have some aspect of that safety training. You're then going to want to develop those performance support materials, including things like checklists, instructional manuals, developing metrics by which you can both train and assess groups or teams. And then guiding that team and organizational design. And so we'll talk later in the semester about things like leadership and organizational design. But one book I highly recommend y'all read, if you want a very quick read, is Extreme Ownership, and it's written by a man named Jocko Willink, who's a former Navy SEAL, but he talks about kind of the nature in which leadership boils down to the leader, right? And so I know that sounds very self-explanatory, but this idea that you would go into companies and companies would say, my employees just are not motivated. What can I do to crack the whip to get them motivated? His whole point is, well, that starts with you, right? You need to inspire them to do these things. And so guiding that team, that organizational design is part of that designing process.
You said that was extreme ownership?
Extreme Ownership, yeah. Yeah, it's a really neat book. If anybody doesn't want to buy it, I think I've got a copy in my office you can borrow. And so you all have likely heard the terms UX or UI at this point. And colloquially, they're frequently used interchangeably. People will say, you know, we're interested in the UX or the UI evaluations of a certain product, but they actually have distinct meanings. And so when we say UI, we mean user interface. And so what are the things of, for example, the graphical interface with which somebody interacts? So when you think about Facebook revamping everything, when you think about Facebook revamping everything on your news feed, that's an aspect of user interface. Yeah, Manuel?
I was gonna say, depending on the types of machine you use, like if you ever use like Linux machines or like Ubuntu machines versus your Windows and stuff, you know, there are some where you don't have a mouse, and so you just have to use your keyboard to do everything versus having a mouse to navigate and whatnot. So it's just, that's the interface.
Absolutely. Yeah, Manuel's exactly right. And so one of the things that blew my mind when I first learned it was that the mouse is actually a fairly recent invention on computers. Everything used to be done in kind of the command line or the terminal, depending on what system you're using. They call it different things. But having something wherein you can actually interact with the user interface like we have is a fairly new thing. And that's one of the things that helped Apple kind of rise to prominence, because their goal was to make it that everybody could use a computer. You didn't have to have any sort of understanding of scripting or coding. You didn't have to be able to use the command line. You would have a user interface. Yeah, so Anna says where buttons are, their shape, color, and how people intuitively think to look for them. Exactly, that's user interface. User experience takes that a step further and includes all aspects of the user's interaction with the system. So Apple products have a very specific user interface, but when I talk about things like the ecosystem or that easy handoff between machines, that's part of the user experience. It's not just the design of the look of the system. It also includes all aspects of my interaction with it.
So it'd be more like things you don't see in the cinema.
It's a combination. So some things are things that you see. So for example, one thing you wouldn't see, at least working directly, is the startup procedures for a computer. Apple tends to try to get a rapid startup and then kind of lags a little bit on the back end, getting other applications up and going, whereas Windows tend to lag a little bit at the onset, and then the apps are ready to go back there. But then you do have kind of the actual things that you do see. And so, so like on any Apple product, I'm going to keep going back to Apple because that's just what I'm most familiar with, you have the experience of being able to press and hold down any app on it to get that additional things. And when you do that, you tend to get a little haptic feedback, right? Your phone vibrates a little bit. It's indicating that something happened. You also get that with the newer generation iPhones, wherein you have a button down there that looks exactly like I have on my iPad, This button actually clicks. The button on my iPhone doesn't click, it doesn't depress, but it gives you a haptic feeling, haptic sensation back to make you think that it was actually clicked. And so that would be kind of more of an obvious user experience thing than under the hood. But yeah, it does comprise both. And so one of the things you all will see when you go out into the real world and start doing this type of stuff for companies is a debate about when do you consider the human, right? We're now finally getting to the point as a field where we're convincing companies that they at least need to employ human factors engineers. But a lot of companies tend to treat human factors folks as kind of the, check the box activity after the system's been designed, right? We've designed a system and we want somebody to come and say, yes, you did a good job, so we can go get that government contract. But in reality, the sooner you start considering the human, the better. You don't run into that problem like we had with the F-35 that we talked about last class, where the helmet's so heavy, you have to pause everything, go through a complete redesign of the system. Saves money, saves time. You'll also notice once you go out into the real world that the decision makers love the buzzwords. They love UX. They love things that are ergonomically designed, right? But in reality, there's little consideration at the forefront of including these actual designs. And again, just this post facto thing of saying, yes, this is a very good design from the, principles that we know about attention. Well done on that. So if you can incorporate the human, consideration of the human early on, you're going to be a lot better off. Now, some of my favorite examples of why human factors matters is what happens when you don't consider the human. So even simple things in design can be done to prevent catastrophic errors. Let me pull up this website here. All right, 10 proofreading mistakes that cost millions of dollars. I don't know if you can see this. Let me zoom in quick. Back in 1872, the US government put one misplaced comma in the US Tariff Act. Instead of waiving tariffs for fruit plants, they accidentally waived fees for fruit, plants, costing about $2 million. A Japanese financial company once accidentally listed 610,000 shares of a company for $1 each, rather than one share for $610,000. Italian airline accidentally listed business class flights for $39 instead of $3,900, resulting in $7 million lost. Yeah, another $9 million compensation here. Yeah, again, listed the shares you want to sell off on the actual decimal point. Lottery tickets. Where is, let's see. Yes. So in 1962, the Mariner 1 space probe exploded shortly after takeoff. NASA investigators later determined that a missing hyphen in its guidance software resulted in a series of false course correction signals. I don't know if that was mine or y'all's. The rocket was then deliberately detonated to prevent it crashing into a populated area. So it's easy to say, okay, well, what the heck does this have to do with considering the human? These systems should have been designed to prevent stupid errors like that, right? There should have been something in that Japanese financial company software to say, are you sure you really want to list 610,000 shares for just $1 here? There should be some sort of kind of idiot proofing, if you'll pardon the phrase, to prevent things like that from happening. So as the manual said, you know, the old case with computers, you didn't have a mouse, you didn't have a user interface. You would literally just type things into command lines. And if any of y'all still do that, you'll know it's really easy to delete things and you can't undo it, right? We're all used to this experience of, are you sure you want to delete this? It can't be undone. Well, if you go to your terminal or you go to your command line and tell your computer to remove that file or that directory with everything inside of it and execute it, it's gone. Can't undo it, right? And so you have to think about what are the small little mistakes that somebody could make in software or on some sort of, I don't know what they were using for the Mariner rocket there, but in some sort of coding environment which errors result in catastrophic second or third order effects. You also may be familiar, and you may know the story better than I, of the NASA, and I think it was the British equivalent of NASA, collaboration on the Mars rover. And there was a failure in conversion between imperial and metric units, which wound up resulting in the Martian rover slamming into the surface of Mars, costing I don't know how many billions of dollars it was. But yeah, there should be things that we can design to help prevent things like that.
They had proofreaders, but somebody missed that. And they used to code all of that in like ionized metal rings.
Yes.
And so it went from hands to metal rings. Yeah.
Oh my God, that is the most impressive display I think I've ever seen at a museum. If y'all haven't seen this, go to the Space and Rocket Center, and they have some of the onboard computers that they would use for the Apollo missions. I think it was that they had.
It's called the instrument unit. If you go into the Saturn V, it's a big old ring. It's almost as tall as this room. And it's all coated with tiny copper rings, and they ionize them to be negative or positive, which would be a 1 or a 0. And they code it all like that. And this whole giant ring that costs millions of dollars has less power than like a singing like card Dollar General.
Yeah, yeah, exactly. So they would essentially just hard code in this binary with the polarization of these little rings wrapped around, I guess it was a copper mesh or something. I don't know what it was. But yeah, it really is remarkable. And you can see how easily something like that, if there's no real compiler that you can run your code through, you miss a hyphen and all of a sudden, $150 million down the drain. I'm going to keep picking on the U.S. Air Force, even though everybody is guilty of these types of sins. Another really interesting story is the fact that the F-22, which was another one of these kind of 5th-gen fighter aircraft that had, I don't know the exact number, but thousands of sensors on the aircraft itself to detect any sort of abnormal states of the aircraft, had 0 sensors on the pilot themselves. And there were a couple high-profile cases where the pilots lost consciousness. It's not sure if they went hypoxic or what happened, but they lost consciousness and crashed the aircraft, right? Because we have thousands of sensors on this incredibly advanced piece of technology, but we didn't think at any point to start trying to detect what's going on with the human. And so you get after the fact engineered solutions like this auto GCAS or auto ground collision avoidance system let me show you this video real quick because it is a really cool demonstration. If I can find my mouse. Maybe. All right, come on, where are you? There we go. Sorry, you're gonna have to watch Google Fiber ad. I think it heard me talking too much good stuff about Apple. All right, so this is a video from a heads-up display of, I think it was an F-16, and the parts that are blacked out are the classified information. What you see here is the pilot pulling a high G turn. In just a second, you're gonna see the aircraft nose over. There we go, nose is over. The pilot's lost consciousness at this point, and it's heading towards the aircraft. You can see the altitude on the right-hand side, down to 12,000, 10,000. And what you saw there with those arrows, those chevrons coming in from the side, was an indication that the aircraft had detected a collision course and needed to be pulled out of that to avoid colliding. And yep, you've already recovered here. Let's go back real quick. Yep, so getting down, I don't know at what point it pulls up. Yeah, so it starts, it makes a decision at 8,000 and then bottoms out at just over 4,000. And I don't know what the actual ground altitude is, but this is an after the fact engineered solution, right? They didn't consider the human before. And the really interesting thing about this auto GCAS system is it has no sensors on the human still. It can't tell when the human's lost consciousness, when the pilot is out. What it does tell is when the onboard computers think that the system is on a collision course. And it pulls out at what it perceives to be the last possible minute, or second actually, to get out of that dive to be able to stabilize and allow the pilot to regain consciousness and continue flying. But again, because there's no sensor on the human, there are a lot of pilots who actually don't like this system, right? Because in dogfights, they feel like they have to have every possible advantage in the actual maneuvering of the aircraft to maintain dominance in the skies. And so you hear pilots say things like, you know, the auto GCAS system pulled me out of a dive before I was ready. I still had full consciousness. I know I had about another half second before I had to pull out of it, right? And so again, you're dealing with problems of no sensor on the actual pilot themselves and trying to interpolate based off of performance data of the aircraft. Dennis says, do you think that's economics? The plane is more expensive than the human. Dark, but possibly true. Yeah, I mean, so the unfortunate truth is there are those types of calculations that are made. But I don't think that's really the case. I think one of the major reasons that there's no sensor on the pilot that's detecting loss of consciousness is because it's actually a really hard thing to detect. And so when I was at the Air Force Academy, one of the projects we were working on was using an EEG, so an electroencephalogram, which looks at patterns of brain activity to try to see if we could detect kind of simulated loss of consciousness activities. The problem is any of those brainwave monitoring technologies are really sensitive to vibrations, right? And so you put it in a cockpit, it's inherently hard to differentiate noise from actual signal. And so it definitely could be, but when you think about the fact that it's hard to disambiguate the pilot from the aircraft in almost every one of these scenarios. it would make financial sense to actually have sensors that can predict the human state and take control when appropriate, but not too early. All right, any questions about what we've covered so far? Aside from the fact that it's starting to look like end of days outside.
I got an alert from the Rocket Center. It's storming over there.
Oh, good.
Yeah.
Awesome.
I do. Yeah, so I'm on like their GCAS system. Even when I live in Tennessee, I get texts. I'm like, oh, they like these guys. So I just got that message. I was like, oh, that's nice.
Yeah.
I do work there though. Let me see them.
All right, I'm not seeing any questions. Any of you Zoomies, feel free to type into the chat box if anything comes up. All right, so we're going to talk about 3 different design processes. Your book details them, and I'm sure you're familiar with them, especially if you come from the engineering side of things. But there are a lot more that exist outside of just these 3. So you'll at least get an idea kind of the breadth associated with kind of the framing, at least in the contrast between the V process and the Plan, Do, Check, Act / Scrum approach. The bottom line of each one of these is that they're used as a way of creating, evaluating, and understanding. So the V process, named because when represented graphically, it literally looks like a V, is particularly used for high-risk domains. So think about space flight. You can't have some sort of iteration that you don't know exactly how it's going to play out over the course of a launch. So what you want to do is break down every component of that, every interaction of that engineered solution, and figure out, okay, not only what are the primary effects, but what are the secondary, tertiary, and so on effects, downstream effects, both on the human and on the other components. And so you have 2 different stages. One, you have this kind of decomposition and definition, the documentation, and then you have the integration and recomposition phases. So in that decomposition phase, you're really exploring that concept. What is the thing that we're really concerned about? What are the things that either need to be fixed or things that we want to add to the capabilities? Come up with your management plan, concept of operations, or you'll sometimes hear that called ConOps. You'll establish what are the system requirements, right? And so this is always an absolute essential when you're working with customers to get what do we need this system to do exactly. So any of y'all who may go into government contracting, you will get documents from the government that say, we need this software, this hardware, this weapon system, et cetera, to do each of these bullet points. And then that is upon which you will be graded when it comes time to actually deliver the product. You'll come up with your subsystem design. So within the whole, what is that smaller component that you're going to be dealing with? Then you move on to a more detailed design based off of those preceding subsystem designs, based off of the requirements, which are based off of the ConOps. And then you actually get that component implementation, right? And so that's you actually putting it into the system, whatever the system is. And so that all makes sense from kind of that decomp approach. But the reason this is really used is for that integration approach. So now what you're doing is you're building up the tests. you're starting at that unit. You're testing to make sure that that unit does exactly what we programmed that unit to do. Once you pass that step, you get into that subsystem verification. So is that subsystem, that small component that's still bigger than the exact engineered solution, still doing what we want it to do? Moving on to the system verification. Is the system still doing what we want that system to do? And then you get that system validation. And so that's where you're making sure that, yes, in fact, this rocket can lift off and do so safely. And you can see this type of process with SpaceX of late, right? They took a lot of really slow, laborious steps to get to the point where they were even allowed to launch test pilots up to the International Space Station. And you can see the development of each one of these phases. Now, you typically are only seeing kind of at the later end stages where they're actually doing the system validation of re-landing those Falcon rockets. But you can see when there's a disaster, them talk about the reiteration, going back to the beginning. What are these system requirements that maybe weren't met, or aspects of the design that need to be changed? Yeah.
I wanted to ask, can you have our understanding the difference between system verification and system validation?
Yeah. So system verification is going to be actually making sure that the system itself is going to be doing what you want that whole system to be doing. The validation is putting it into play. And so making sure that in actual action, it works. Right? Does that make sense? The differentiation? Good question. Yeah. So you have the system verification, which is essentially just making sure that that system is doing what you want it to based off of those system requirements. So you can see you have that horizontal line between the two sides. So the system verification is trying to respond to those system requirements, make sure that you are actually meeting what the government or whatever the customer decided needed to be met. And then the system validation is integrating that system into the real world and make sure it works and fits in with that kind of concept of operations. Does that help? Perfect. Yeah. And so y'all can see how slow and deliberate this process is. This isn't going to be good for a tech startup, but it's going to be good for a company wherein there are real potential catastrophic consequences of poor design. You then have what we call the plan, do, check, act cycle. Very uncleverly named because it literally is you planning. So identifying what problems are you trying to solve. Doing, so you're actually going out and testing potential solutions. And check those results, those data. And then actually act and implement that solution. And so you can see why something like this, at least on a large scale, or kind of meta scale, wouldn't really be the best approach for a company like SpaceX. It would be a remarkably expensive process of saying, all right, well, let's try this type of feat on the entire rocket for the landing and see what happens, right? That actual implementation carried out, you then get a rocket that explodes, and you have to start from square one. So this is better for kind of low risk domains, domains in which consistent, quick iterations are going to be better, both from a time perspective, but also financially. You then have the Scrum approach. Scrum also seems to be one of these kind of buzzwords that if you want to sound like you know what you're talking about, go into a room and talk about kind of your Scrum approach to design. And this approach tends to be used by a lot of software companies where, you know, it really doesn't matter that the product's perfect when it first gets out. Especially for a lot of startups, what really matters is getting the product out, being first to market. You're going to have bugs, right? But getting that user feedback, either deliberate feedback, so users saying, I like this and I don't like that, or performance metrics, you're then able to iterate and come up with additional solutions to problems that arise. And so what you'll get here for that product backlog is literally just a list of things that need to change. So let's think within any sort of Facebook rollout. Maybe they need to change kind of the coloring in certain areas because it's not in compliance with Facebook standards of appearance. Then they may also have an issue wherein hitting the back arrow actually takes you all the way back to the beginning of Facebook rather than the previous page that you wanted. And you can come up with a list of things that would be, okay, what do we need to change? From there, you're prioritizing, okay, what thing do we need to change first? What is most important, either to the efficacy or the safety, etc. So I just started reading a book about Stuxnet. Does anybody know what Stuxnet is or was? So this was a computer virus that was put out in an attempt to disrupt Iran's nuclear program. It was a computer virus that jumped from computer to computer, essentially just laying dormant until it found a certain set of system capabilities, at which point it went into action. And I'm at the point of the book now where they're talking about, okay, they discovered this loophole in the Windows operating system, and it took Windows 2 weeks to patch that hole in the security once they discovered it. And so it's not like that Windows shut down everything. They said, all right, we're terminating all Windows operating systems. They kept it going, but now at the top of that product backlog up here, they said, okay, we've got a pretty big, serious security issue that we now need to design a solution for, right? And so there are a couple ways you could think about it. They probably created a patch, put it out to market, and then they got that feedback. And while the patch worked, there were second order effects. So maybe the patch now interfered with Microsoft Word working fully well. And so that creates new backlogs or new things that need to be fixed. And so this is one of the reasons why it's so, so Dennis, it's also sometimes called Agile. There are a lot of different names. One of the things you'll notice within the business world is people love to rebrand the exact same thing. And so people will do the same thing repeatedly, but call it something new and exciting. You'll see this with things like artificial intelligence. It's really just big data processing, which is really just a derivative of multiple regressions. But if you say you're employing artificial intelligence to answer these questions, that sounds good. Yes, extreme Doritos. Yes. Yeah, so hopefully y'all can see kind of the difference in where these sorts of processes would be at play. What questions do we have about these different design processes?
I'm just curious, I'm just looking at this, the Scrum approach here. So I get the product backlog, does that make sense?
Mhm.
Explain. I assume the sprint backlog is maybe like some things that need to be done a bit quicker, maybe, or something. And then like the sprint 4 weeks is like, yeah, within 4 weeks to turn around, either finish or bring it back and restart, or.
Yeah, so the sprint backlog is going to be, what are the things, so we've identified this, let's say in the Stuxnet example, Windows has identified this security patch that needs to be put out. They've subsequently broken it down into smaller things. And so part of that may be, changing the operating procedure once a USB is injected, changing then the actual scanning process for all the files on that USB, et cetera. And so you can see how you have this main tasker, but then you break it down into the smaller components. And that's what that actual sprint backlog entails. And then, yeah, so the actual length of these sprints varies dramatically, and also is going to depend on what you're trying to do. But yeah, so this kind of 4-week process would be, get it out to market, you get some of these reviews, you have kind of the beta tests in some of these cases, reiterate on what needs to be changed, get it back out to market, et cetera. Good question. Any other questions? Yeah.
So sprints, is it like it's like a time period within which to do work, right?
Mm-hmm.
And does it vary?
Yes. Yeah. So it's really going to depend on A, what the task is, B, how much you have available to you at the time. And so when I was at the academy, one of the things that the Air Force recognized is that anything within the government moves really slow. And so they wanted to be able to create these systems that, or these processes by which they could have really quick turnarounds on really innovative ideas. And so they would have what they would call these design sprints that were just a week long. But then you would have kind of from that, take it and expand out. But they were kind of constrained by the fact that they would pay, these brilliant minds from everywhere in the country or world to come in to help with that. And so it would be like a 1-week design sprint with kind of these multiple iterations, et cetera. But yeah, I mean, much longer and you're not really kind of leveraging the benefit of a sprint, right? But the whole idea is small changes, get them out, keep building on top of it. Good question.
Can you hear me, Nate?
I can.
Are there positions out there in the world? Because I was thinking these systems in and of itself could have, I mean, in essence, this is a user experience for the people designing. Do they have, positions in companies that actually you have a UX designer looking at the actual process and looking at metrics? Because I've seen like hybrid Scrum methods and stuff like that, where you have somebody actually, maybe even a program manager that's in charge of, is the Scrum approach working? Can we do that better? Where it's almost kind of like a meta.
Absolutely. Yeah, that's a really good question. And so one of the things that big companies will do is have what's known as IO psychologists or industrial organizational psychologists come in. And they are really focused on things like the training, efficiency, both in personnel selection, things like that. And so, I think any organization should be focusing on how can we enhance the efficacy of these approaches. Are the Scrum approaches best in scenario X, Y, or Z? However, most of that kind of theoretical work is done at the university level. I don't know of any off the top of my head cases where I've heard people directly talking about that sort of evaluation of that, but you can absolutely see why that sort of evaluation would be useful to say, okay, this is part of the sprint that doesn't seem to be giving us much return on investment in our time. So yeah, I don't know of any specific companies that have at least a sizable component of those kind of introspective researchers looking at the process, but if you can find any, I would love to hear about that. All right, I'm going to go ahead and move on because I'm being long-winded today and not getting through everything that I need to be getting through. But for those of y'all who are doing the consulting project, you got an email from me detailing essentially what's on this slide, right? Every time we go in as a human factors engineer, we have to conduct some sort of front-end analysis. It's essentially that who, what, when, where, why, how, if you want to add the H. Who are the users? Are they college students? Are they geriatric patients? Are they athletes? Why do they need the product? Remember, I showed that Steve Jobs quote last time about making products that help people realize kind of their goals and their dreams. And so that why may be for the consumer. Maybe you need to convince them why they need that product. Or maybe it's the actual customer themselves, and you're kind of helping them see, okay, why do you need this change in your company? What are user preferences? Doesn't always mean you have to listen to the preferences. You know, another real world example, the F-35 has a touch screen in the cockpit rather than actual controls. The problem is, when you're flying at high speeds, the plane vibrates a lot. And so getting in and pressing the touchscreen isn't really all that efficient. So what pilots wind up doing is putting their finger in the corner of the touchscreen, dragging it up to where they want it to go, and then releasing from there, right? And so the preferences initially were, let's have this futuristic kind of modular touchscreen approach, but that's not necessarily going to be the best, and that's where you get into the actual evaluations we'll talk about throughout the semester. What are the environmental conditions? Obviously, you don't want fragile technology in a really rough environment. Physical and organizational context of users' activity, major functions, and then when must tasks occur, in what order, and how long will they take? Right? This is not a completely exhaustive list, but it at least gives you an idea of what type of questions you should be asking when going into any one of these scenarios. When I go into consult, the answer is not, what do I, Nate Tenenfeld, want to design or help you all design? Every solution is going to differ by the company, by the overarching goals, the environment, things like that. Important to keep in mind for your semester-long projects. All right, we're going to skip the critical thinking activity, but it'll be a good practice for you all at home. You know, think about a place wherein you have worked before and see if you can establish what are those kind of answers to the front end analysis questions that you would then be able to engineer solutions for after the fact. And your book also identifies a 4-step process for task analyses. Again, you're seeing kind of a pattern here with any of these design processes. You know, establish the playing field. From where are we operating moving forward? You want to collect the data, you want to interpret the data, and then innovate from there. I'm going to go over each one of these a little bit more detail. All right, so first and foremost, defining the purpose and the required data you need to collect. So first, establishing why are you even doing this? Are you trying to estimate system reliability? Are you trying to redesign processes? It's hard to get the right data if you don't know what the right problem is or the right question is. So what sort of data do we need to collect? Well, one would be potentially hierarchical relationships. So what, why, and how are tasks performed? Things like the information flow. Who's performing the task? Who needs what information? What are the feedback processes? That sequence and timing too. In what order and how long do tasks take to perform? If a product has to go from me to Andrew, back to me, and then to Kelsey, that may not be the most efficient way, right? Maybe it starts with Andrew and then stays with me for a little bit longer so I can get through both my processes and then send it off to Kelsey. Location and environmental context. So again, where and under what physical and social condition are tasks being performed? And then we collect the data. So when we talk about data collection techniques, we have a couple at our disposal. Observations and questions of people as they're using an existing system. So maybe Emmanuel's trying some new technology that I just established, and I'm just going to observe him using it. What are the sticking points? What are the things that aren't going well? And then maybe just ask him, okay, what do you think so far? What don't you like? What do you like? Can you find this submenu? Retrospective and prospective verbal protocol analyses. So asking people, what did they do? Or what would they do? Walk through step by step. You also have focus groups. I tend not to be a big fan of focus groups because very often people don't know what they think until they're forced to come up with a justification for thinking something. You also have social dynamics at play. And so if I perceive Andrew to be the leader of the group, when Andrew says something, I'm more likely to agree with it. You also then have surveys and questionnaires. All of y'all are probably familiar with those. And then you have things like automatic data recording. So anytime you download a new program on your computer, you likely have the option to send anonymized data back to the company so they can collect that performance and user data. And so I'm about to show you three kind of graphical representations of that data. One would be a task hierarchy, so goal, task, task decomposition. So let's say you have the goal of a car door. It's to keep the passenger and all the belongings safe. Your task is to lock the door to keep everything safe. Your subtasks then get broken down into inserting a key and turning a key. You then have task flow, and so that gives you kind of the control and the decisions regarding flow from one process or one decision or one task to another. And these will likely look familiar to you when I show you to you in just a second. And then you have a task sequence, so task duration and sequence, as well as modeling or graphing or representing the communication between system components. So here's a task hierarchy. So we're going to start from the root of managing our medication. You can break that down into 4 kind of subcomponents. First, you have to set your reminder. Secondly, because you have to take it first thing in the morning, you have to wait overnight. Then, once you wake up, you have to see the reminder. And then you have to go through the process of actually taking the medication. And then you can see how each one of those sub-steps get broken down even further. So first, to set the reminder, you have to first find the pills to put them in a place to set that reminder. Simplistically, waiting overnight involves you going to bed, you sleeping, and then you waking up. You see the reminder, walking into that room and noticing the pill, and then taking the medication. And so by doing a task hierarchy like this, you can see all the potential points of failure. If I just never walk into the sitting room, that's the point of failure for the system. I don't wind up achieving that end goal of managing my medications. You then have your task flow data. And you guys have seen memes, versions of this all the time. But you come to individual decision points. And based off of each one of those responses, you have a different action. Or potentially that leads to another question. And you go through that actual flow. The sequence diagram is that little bit more complicated one, which is detailing the length of time, but also the communication between subcomponents. And so sequence diagram for you going to get money out of the ATM, you first insert your card into the ATM. The ATM then tries to communicate with the bank server to verify that's a legitimate card. If that card is okay, that signal comes back to the ATM to say it's good. The ATM then prompts you to enter your PIN. If, however, that card's invalid, it sends that signal to the ATM. The ATM ejects your card, and you can see how this then plays out for each one of those steps. This helps in both identifying a priori any potential failure points, but then also kind of solving any failures that occur in an actual software or in an actual program. Okay, what didn't happen? I didn't get my card back. So was there a problem verifying the card? Is there a connection problem there? Was there something wrong at the bank server in that they couldn't verify it one way or the other? Or there was a crash and now we're waiting on that server to reboot? Or is that signal never received back by the ATM, etc.? All right, we're going to skip that real quick. Does anybody have any questions? I know I'm kind of breezing through this a little bit, but I don't want to leave too much for next time. All pretty straightforward? Cool.
Well, I got a question. It's not exactly related to what you just said.
Yeah.
Well, you just mentioned crashing. I made me think. I thought it seems like, like modern computers crash and stuff like that, a lot, or at times, right?
Mm-hmm.
But I've never heard or known anyone who talk about like medical machines crashing. That's maybe they just use really simple systems that are like overly powered to make sure they don't crash. Or
You said the medical systems?
yeah, medical systems.
Yeah.
Like stuff like that. Yeah, I've never heard of one crashing.
Yeah, so that's probably a component of a couple different things. One is redundancy. So like Teslas have 2 computers running simultaneously, completely parallel from one another, such that if one crashes, the other one can pick it up. So it's probably some component of that. It's also probably an aspect of being over-engineered. And so, I mean, if you think about taking your laptop and instead of doing everything you're doing on your laptop, you just decided to only use a calculator. Chances are it's got all the capacity it would ever need and it'll never get overloaded. But that's a really interesting question. I don't know, and it probably varies from system to system, but I suspect there is kind of a redundancy component as well as an over-engineering component.
I was just thinking, you know, like, in this class, maybe was making me think, you know, people's lives on the line, where like that, with the jet situation, that F-22, you know, whatever, people's lives are on the line. I said, well, in medical systems, you know, they really hear, oh, that's crashing and someone dying because of it, because it's never heard of it. I mean,
yeah, absolutely. So one of the things that NASA did after was it the Challenger or Columbia, the O-ring disaster? Challenger. Okay. Yeah, so after the Challenger disaster, NASA realized, okay, that was a single point of failure, right? The O-ring goes, the rocket destroys itself. And so creating these multiple lines of redundancy is kind of where you go for any of these high-risk domains. And so that is typically what you get in some like military settings or in things like your vehicle itself. There are fail-safes, and then there are also kind of, we're going to, you know, engineer it such that there are two computers running simultaneously. So if one fails, we don't have to worry about that. Or there are multiple kind of redundancies into the actual physical design of a system, such that if one O-ring fails, the entire rocket doesn't explode. That's a very good question. All right, and then the final step of that is just the innovating from that data, right? So you've gotten the data, you've taken a look at it. What are the things that need to change, right? And so if any of you wanted to be inspired to go make your first billion before you reach 30, take one of these and see if you can model something in your life that's changed as a function of the coronavirus. And what are those areas of inefficiency that you can now design a solution to help address based off of those flow diagrams? And I will take just a small cut, and you guys are all billionaires. So again, we present this task analysis as a one and done, as a sequential process. But as with everything in human factors, we're requiring iterations, right? So you can think about the prototyping process. You build, you test, you evaluate before you rebuild it. And so how are we evaluating how we did? We use what's known as a quality decision matrix. Oh, I heard some grumbling. Yeah, so we can look over here on the left-hand side, and these are our requirements. These are things we need a system to have. We then give each one of these requirements a relative importance. So we can see the requirement 6 is most important, followed by 2, followed by 1. And then the columns, think of these as products. Maybe feature isn't the best word for it, but these are just products. And so now we're evaluating, right? So we have product 1, we see, okay, how does it do on each one of these requirements? Product 2, same thing. Product 3. And then to make our overall evaluation, we're just multiplying the ranked value or the score value for each cell by its importance, and then adding all of those up. So let's say the way we are calculating this is we will give a great score on whatever we're evaluating as a 9, 3s will be eh, and 1 will be awful. And if there's no score, the product didn't have that requirement built in. And so now you can see, all right, so we're going to multiply 3 by 22, 66, 9 by 86, I don't know what that is, 9 by 8, 72, add all those up, and the total we're going to get is 912, and we're going to do that for every one of these columns. From there, we can get the rank order, right? And so this is as close as you can get to objective decision-making based off of a priori or ahead of time classifications of relative importance, and also as a function of what are the requirements we need that system to have. And so when you go home for a practice activity, think about how you would create a decision matrix to find a significant other, right? What are the requirements those significant others have to have? And then rank perhaps your previous significant others to see how close they were to kind of that ideal. And so because this is an iterative process, we're going to frequently have prototypes or wireframes or mock-ups that lead to the eventual testing of it. Right? And so a wireframe is just this very basic, we know we want to design an app. Let's just get onto Microsoft PowerPoint and draw some boxes to give us a general layout. We then get to the mock-up phase, and the mock-up phase is what do we want it to look like exactly, but we're not worrying about functionality yet. We're just mocking it up. This is going to be the actual layout based off of that wireframe design. And then the prototype is going to be a functional system. So now we have that mock-up, but that mock-up can do things, right? And so this is where you'll get some of those beta testing software. They will have this prototype. They want some early feedback, or this is the prototype you can take to the customer and say, you know, this is how it's going to work. What do you think? Then you can change and iterate on that prototype, hopefully not having to go all the way back to the wireframe and mock-ups. And there's some really cool early prototypes floating around on the internet. Here are the early prototypes of the iPhone. You can see the differences from one prototype to the other, but also from those prototypes to what the final product turned out to be. Here was Nintendo's first attempt at, what do they call it now? The Switch, yes. This was their first prototype for the Nintendo Switch, right? Take Wii controllers and put it on a little screen. Did you? I love it. The initial prototype for Super Soaker was actually devised by somebody who was trying to build a better refrigerator. But when one of his custom machine brass nozzles blasted a stream of water across the bathroom, he decided to abandon that and move on to the Super Soaker idea.
That looks like something highly illegal right now.
It does, doesn't it? Yeah, in fact, I'm probably on a watch list for even showing you all this. Oh. All right, so you can watch this video at home. We're running out of time. All right, so what questions do you all have about what we covered today? Andrew.
Like when you're going about taking all the different preferences and like assigning a score to them, like, is there any kind of like test or scale that you take to determine those scores?
Yeah, that's a very good question. So let's go back to that decision matrix. There we go. So your question is, how do you get that importance value? Is that right? Yeah, so there are a couple ways you can do it. One, you could just do a simple poll of everybody in your company. Say, okay, what's the most important thing to you for this new product? And so maybe, requirement 1 is 50 of your current employees said, we need something that does this, right? You could also attempt to try and quantify the financial loss associated with poor performance on one of these requirements. And so, just think about the difference between a crappy computer and a good computer. A crappy computer is going to run a lot slower. And so now we've said, okay, there is a 30% reduction in the overall efficacy of the performance of each one of our workers at each one of these stations. What is that costing us in money? And then now I can do that for every single requirement. And so I can get a relativistic evaluation. I mean, these numbers for importance could be anything. I mean, it could just be 1 to 10, or it could be an attempt to concretely establish, what is the cost or what is the potential savings or benefit to the company. And so there's not really a be-all, end-all for this, wherein you have the opportunity for objective metrics. You're going to be better served by actually trying to go with that quantification. But there are kind of a lot of ways to skin that cat. That makes sense. Dennis says, I've seen the decision matrix used at Pixar for choosing what software developers work on based on how important it is to the animators, as well as how cool it would look versus how hard it would be developed. Yeah, absolutely. And so again, you can use these for product evaluations, but you can also use these to try to be an optimal decision maker. There's a book out there called Algorithms to Live By, and it is truly an attempt to quantify the optimal decision you can make on anything. Like, how long should you search for a parking spot before you pick one? What's the best, mathematically, what is the best way to find somebody to marry? Things like that. And so you can approach this in a much more, as a psychologist, we are really flawed in decision making because we have a lot of biases and heuristics. But what can we use, for example, with this quality decision matrix to really help try to quantify the best decision in those cases? Other questions? All right, well, if there's nothing else, I will hang around till everybody hops off of Zoom. Otherwise, I will see a contingent of y'all on Tuesday, another contingent of y'all Thursday. Yeah.
I have a question, not related to class, just about you. I mean, I went through the introduction stuff, but
yeah.
I have a couple questions. Since you're teaching a human factors of psychology, engineering class, basically, are you psychologists? Are you do engineering psychology, like what to help them understand? And then just stuff like that, just out of curiosity.
Yeah, absolutely. So my training is in what's called cognitive psychology.